Now we will represent Werner's theory in the form of structures and see how exactly we studied. Okay. Werner took the example of CONH3 whole 6 Cl3. This is the compound which he took as an example. What is this compound? This I can also write it as COCl3. Hexaamine cobalt 3 chloride. Okay, it is what complex? An octahedral complex. So, if I draw cobalt and I drew a structure around it, so you will find this is how the compound will look like. Its secondary valencies. This is what structure? An octahedral structure. You have 6NH3 and these Cl3. These are all what? Written by solid lines because they represent what valencies? Secondary valencies. The primary valencies are represented by dotted lines. So this is how you will find the representation of CONH3 whole 6 Cl3. Fine? It won't affect the shape because it is what valency? Ionizable valency. So he said if I take this compound, I require 3 moles of AgNO3 to get 3 moles of AgCl. Yes or no? I require 3 moles of AgNO3 because I have got what? 3 Cl. So I require precipitate of AgCl. So how many Cl are present? 3 Cl. So I require 3 Ag. So I require for its precipitation 3 moles of AgCl. Is it clear? Represent this compound after Werner's theory in your notebook. You wrote no Werner's theory? Please write the compound structure. Yeah, that's right. Otherwise, why I would think freedom? Man, so much they have deleted. Why will I teach you more and more here? Primary and please write 3 moles of AgCl required. Octahedral always those 2 bonds are longer. I have drawn shorter, you can write longer. Okay, you can even write this compound as COCl3 6NH3. COCl3.6NH3. That compound can also be written as COCl3.6NH3. Okay, now what I do? I make the next compound which has got CO, NH3 whole 5, Cl and Cl2. What did I do now? I shifted one negative ion inside. This negative ion is satisfying both my primary valency as well as my secondary valency. So now what happens? This NH3, one of it goes. And what it comes here? You get one solid line as well as one dotted line for a Cl. This shows what compound? Again, the same compound. 1, 2, 3, 4, 5. And you have CONH3, Cl2. Okay, one more Cl. One NH3 is removed. Now for this, how many moles of AgNO3 I require?
2.
I require 2 moles of AgNO3. Why? Because its ionizable valency is only how much?
2.
2 Cl. Clear? So please write. This shows what? Negative ions can satisfy both primary valency as well as its secondary valency. Done. Okay, first even mentioned the first structure's color is yellow. COCl3, CONH3 whole 6Cl3 color is yellow. It requires 3 moles of AgNO3. Now the second one, it requires what? How many NH3? 5 NH3. And how many Cl? 2 Cl outside. This is purple in color. And it requires how many moles of AgNO3? 2 moles of AgNO3. Now we will make the next structure, which is what? CO, NH3, whole 4, Cl2, Cl. CO, NH3, whole 4, Cl. This is green in color. So we will change now the structure. We have what? CO, we have NH3, 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 NH3. We have one Cl showing dual nature, another Cl also showing dual nature, and one Cl showing the normal valency. Can you understand the structure? These 4 are showing what? Only secondary valency. This Cl, these 2 Cls are showing what? Both primary as well as secondary valency. And this is one Cl which corresponds to its oxidation number. How many moles of AgNO3 I require? Only 1 mole of AgNO3 I require to precipitate AgCl. Color I told, it is what in color? Green in color. Okay, now what I will do, I will make the next compound as CO, NH3, whole thrice Cl3. CO, NH3, whole thrice Cl3. Now what will be my structure? What will be my structure? This Cl will completely go. And this Cl will again become what? Fine. Now write, the color of it is violet. And will it require any moles of AgNO3? No. It will not require even 1 mole of AgNO3 as no free Cl ion is present, as no ionizable valency is present. This is to prove that negative ions can satisfy both its primary valency as well as its secondary valency. So Werner's theory clear. Alfred Werner basically said the stability of complex ion by giving its bonding outlook in the form of its valencies. He said every metal atom has 2 valencies, the primary valency corresponding to its oxidation number and secondary valency corresponding to its coordination number. The primary valency is ionizable and the secondary valency is non-ionizable. The secondary valencies are arranged in a fixed fashion around the metal atom to give the geometry, which is also called as a coordination polyhedron. The metal atom tends to satisfy both its primary as well as secondary valency. The negative ions can satisfy both the primary as well as its secondary valency. Okay? Now, not given in the textbook, but it is very important. You should know something which is called as EAN. Please write capital E, capital A, capital N, EAN. What is EAN, Chiran? Huh? What is EAN? N is number, very true. What is EAN? It is called effective atomic number. Very true. It is called effective atomic number. Okay. Do you remember some scientist in chemical bonding by name Sidgwick. Chemical bonding and kalpilva. Chadwick studied in structure of atom. Sidgwick, chemical bonding theory. Okay, please write. Sidgwick gave the concept of EAN. SIDGWICK. Sidgwick gave the concept of EAN and stated that the central metal atom or ion, central metal atom in a complex ion receives the electrons from the ligands till the EAN or till the effective atomic number becomes equal to the atomic number of the next noble gas. Andre, I'll explain. If I write K4FeCN6, so this Fe keeps on taking electrons from the cyanide ion or from the ligands till the effective atomic number of Fe becomes equal to the noble gas. Which noble gas? Whichever noble gas it comes, that is krypton after Fe. Okay, so this is called as what? EAN. So to calculate EAN, we use a formula Z minus X plus Y. Please write EAN is equal to Z minus X plus Y. Where what is Z? Atomic number of the metal. Where Z is atomic number of the central metal atom. X is oxidation state of the metal. X is oxidation state of the metal. Y is number of electrons donated by the ligand. Y is number of electrons donated by the ligand. Okay, so now for this we will find out. K4FeCN6, Z for Fe. Scandium, titanium, vanadium, chromium, 26. So Z is 26. Minus X oxidation state. Ido minus 4. So X minus 6 is equal to minus 4. So X is equal to minus 4 plus 6. So X is equal to plus 2. So it is plus 2. Plus how many electrons? Cn is what? Unidentate ligand. So it gives only one pair of electron. So 6 into 2, 12. How much it is? Calculate. 26 minus 2 plus 12.
36.
26 minus 2 plus 12. How much?
36.
36. This 36 is exactly equal to the atomic number of krypton. So it keeps on taking electrons from the ligand till it achieves what configuration? Noble gas configuration. So this is called as EAN, and what we use to calculate the formula Z minus X plus Y, where Z is atomic number, X is oxidation state, and Y is the total number of electrons given by the ligand. You don't write electrons, you write electron pairs given by the ligand. If it is unidentate, it gives one electron pair. Let us try to find out EAN in K3FeCN6. ಮಾಡಿ. K3FeCl6. Find out EAN in K3FeCl6. Find out. 35 ಬಂದ ತಕ್ಷಣ ಏನು ಬರೀತೀರಾ? 35 nearly equal to 36, which is of what? Krypton. Okay, next let us find out EAN of Cu NH3 whole 4 SO4. Cu NH3 whole 4 SO4. Copper ಎಷ್ಟು? 29. You know now how life is. Okay, 29. Oxidation state of metal atom is plus 2. How many electrons? 4 2s are 8. So 29 minus 2 plus 8. 35. Again nearly equal to 36, which is equal to that of krypton. Let us try to find out in one more. Please try making it in CO NH3 whole 6 Cl3. Find out EAN of cobalt. Find out the EAN of cobalt in CONH3 whole 6 Cl3. Find out if cobalt, tell scandium, titanium, iridium, chromium, manganese, iron, cobalt. 27 minus 3 plus 12. 36. Okay. Now these were all Sida compound. Now we will change a little bit. We will change the compound as CO NH3 whole 5 whole 4 Cl2 Cl. Find the EAN of cobalt. 27 only. Oxidation state of cobalt find out ಮಾಡಿ. Cobalt is what? X.
Same thing.
Minus 3 only. X.
36.
X minus 3 plus 12. How shall I explain? Oh, you understood. It is X minus 2 gives plus 1. X minus 2. See, Cl2 is negative charge. So X minus 2 is equal to plus 1. So X is equal to plus 1 plus 2. So X is equal to what? Plus 3. What? Because you are adding 1 Cl outside. So it is minus 1. So this should be plus 1. So this will be X is equal to plus 3. So what is cobalt? 27 minus 3 plus 4 and 2. They will give how many electrons? 6. 6 2s are 12. So again it will come to what? 36. Clear till here? So this is how you are supposed to calculate EAN. EAN you can go. EAN basically talks about what? Effective atomic number. It says that the central metal atom keeps on. I have some work, Preetham. That's why I am telling him to go. Okay. So as a result of it, cobalt keeps on taking the electrons from the ligand until and unless it achieves what? A noble gas configuration. Okay. Next part of it is not there in our syllabus, which is called isomerism. So isomerism in coordination compounds is not there. Both stereoisomerism is not there. And structural isomerism is also not there. So that entire isomerism part is not there. Magnetic properties is there. Okay. So now we have to start with a new part which is called bonding in coordination compound. Okay. Now for state board people, there are hardly 4 compounds given. One, which is CONH3 whole 6 plus 3. Second, NiCl4. Third, NiCN4. ಇದನ್ನ ಬಿಟ್ಟರೆ ನಿಮ್ಗೆ ಯಾವ ಕಾಂಪೌಂಡು ಕೇಳಲ್ಲ ಸ್ಟೇಟ್ ಬೋರ್ಡ್ ಅವ್ರಿಗೆ. ಓಕೆ, ಬಟ್ CBSE ಬೋರ್ಡ್ ಕ್ಯಾನ್ ಆಸ್ಕ್ ಯು ಎನಿಥಿಂಗ್. So what we will do many compounds to study the valence bond theory, but state board will conveniently write these three properly as we dictate. The rest we can do roughly and decide what is the hybridization. Valence bond theory first year do enadu gyapta idea? Empty orbitals hybridized together. Hybridization only result in the formation of sigma bonds. Pi bonds are not formed by hybridization. Hybridization always has a fixed shape. sp linear, sp2 trigonal planar, sp3 tetrahedral, sp3d trigonal bipyramidal, sp3d2 octahedral, sp3d3 pentagonal bipyramidal. You should know the names of it. Same way we will study here that if it is an octahedral complex, it is sp3d2 or d2sp3 hybridization. If it is a square planar complex, it will be sp3 or sp3 hybridization. This is only we have to study in square planar and tetrahedral complexes. So just glance through from your first year PUC VBT to characteristics or VBT to postulates. Agutta VBT postulates nodi and VBT balstini, then I will teach. First in octahedral complexes, then in tetrahedral complexes. Please don't miss tomorrow's class. Okay, please come for tomorrow's class so that we really understand. Otherwise, it is a 5-mark question in PU board. One question will 100% come, 4 marks mainly, and 1 mark will be naming. Same way for you all also, a 3-mark question comes in CBSE along with naming. So we are supposed to do all the complex ions whose names, or most of the complex ions whose names we have written, and we'll find out its hybridization, its magnetic properties, and whether it is an outer orbital complex or an inner orbital complex. Okay, so tomorrow's class will study, but till here please read once and come. Okay, thank you.